So we are from CB10 and I'm the lab leader of this week's lab session. So for today's task, we are going to determine the critical value of coefficient of static friction before the block is moving. And the second one, we are going to determine the critical value of angle before the block is moving. We are going to use a website which is called allphysics.com. So
Hello, I'm Nabila Shahira. Now we will see the critical value of coefficient of static friction. The block is moved or not. First thing first, we must open this website. Second, we put the component in the blank in this website, like we have initial velocity is 0, and then probability 9.8. For the mass, we put 10, coefficient of kinetic friction 0, angle is 30. To try one by one from 1.0 until 0.0 and then click start. When we see the block is unmoved, we put X. But if it's moved, we put yes. After we change a different coefficient of static friction, we want to try the number it's going to unmove the object is 0.588. We get from the last value. Also, we want to prove the formula will get 0 or not. We put the value and we see 0. Mine I. For the value of block is moving, we try is 0.544. Prove the formula, we get more than 0.
Hi, I'm member 3. I will explain the angle experiment in table 2. We stay to use the same website and then we going to key in the same value to website. If we put 0 is not moving, so we have X here, and when the angle that is moving, we put yes here. Then we find the final angle for angle not moving and angle is start moving. We put here to prove it equal to 0 or not.
Hi, so I'm going to show how to solve the discussion part. The first question, referring to task 1, different coefficient of static friction, if the mass of the object reduces, will we have different coefficient of static friction when the block is still static? Use the formula given to prove your finding. So, the formula given can also be equals to mg sin theta minus coefficient of static friction when block is still static, mg cos theta. Now, all we need to do is just insert the value into the formula. But don't forget to change the mass value because we want to see if we will have a different coefficient of static friction when block is still static value if the mass of the object reduces. Therefore, after the calculation, we will get the answer 0.557, which is the same as the value when the mass of the object is 10 kg. So we can conclude here that the coefficient of static friction stays the same because the mass of the object doesn't affect the coefficient of the static friction when block is still static. Now, let's move to the second question. Referring to task 2, different angle, if we change the material of the block and plane from wood to steel, do we expect a higher angle before the block start moving? Now, let's refer to the table given. In the table, we can see that wood on wood is 0.42, but if we change it to steel on steel, it will be 0.74. Now, what we're going to do is use the formula given and then do the calculation, and we will get tan theta equals to 0.74, which is the value of the frictional coefficient of the steel. Then we will get the value of the angle, 36.5 degrees. So yes, we may expect a higher angle before the block start moving if we change the material of the block and plate.
Hi everyone, I group member number 5. I will talk about calculation task 1 and task 2. Calculation task 1. In calculation, static friction is a factor moving the block. For case above, the critical value coefficient of static friction when the block is moving 0.557. For calculation task 2. In calculation, angle is factor moving the block. For the case above, the critical value angle of the plane when the block is moving 22.8